We are looking at lesson 21. Here. And any mails where 2 students need to pass, by all means, just ask. Okay, if you're going to lunch and you don't think you need to pass, then that's fine too. Okay, lesson 21. Translations of functions. Graphs of rational functions 1. Okay, this is a reoccurring theme throughout the year. Okay, I can't remember, do we get up to graphs of rational functions 3 and 4 maybe? I don't know. There's definitely several, and we're going to be working with them as the year goes on. Today's just kind of some of the intro for 2 kids are using right now. The translations, okay? So just remember, when the plus or minus the number is in the parentheses, it's moving the graph left or right. What's the key there? Yeah, it's opposite the sign, isn't it? Okay. And then if the number is not in the parentheses and just at the end, it's moving it up or down with the sign. Okay. So, example 1, graph the function y equals absolute value of x. Then change the equation to shift the graph 3 units to the left and down 2 units. This literally could be a problem on their test right now. I mean, it's the same exact, idea of what they're doing here. But, so, what do you guys remember about the function y equals absolute value of x? Okay, it's that v. What about the basic v? Okay. Okay, so that basic v has the vertex at 0, 0. Each side goes up 1 over 1, or as Daryl was saying, 1, 1, 2, 2. That means the other side, negative 1, 1, negative 2, 2, right? This sounds familiar? I mean, 2 years ago you were taking a test on this, so. Okay, so what if change the equation to shift the graph 3 units to the left and down 2 units? So what's my graph doing now? Yeah. And if you recall, the easiest thing is to move the vertex and then move the rest of it with it. Okay? Yes, sir?
I don't know if I can ask you this.
I don't know either.
When it says like this up here, does it want us to put that on the end? Or like, I don't understand what that has to do with.
That is the function that you are doing these things to.
Okay.
Like, so you're not saying it's not going to still be f of x. You're using the x squared and moving that left 8 up 7.
Okay, I see what you're saying.
Okay?
All right, thanks.
Okay. You don't need a pass, do you, Allie? No. Okay. Okay, Calc, did you graph this without me? Hey, no tapping and sharing answers here. Okay, so 3 units left, 1, 2, 3, down 2 units. My new vertex is here, yes? And then what am I doing on each side? Same thing, right? Up 1 over 1, up 1 over 1. Up 1 over 1, up 1 over 1. It doesn't say to, but I have it written here, so let's practice. How would you write the equation for this?
Y equals absolute value of x plus 3, then subtract everything, and then minus 2.
You guys agree with Mallard? Y equals absolute value of x plus 3 shows the left 3, and then minus 2 is the down 2. Okay, so that's good. Some good Algebra 2 review. I think you technically learned these graphs in Algebra 1, really, but. Okay, example 2. Graph the function y equals 1/2 x squared. Then change the equation to shift the curve 3 units to the right and up 2 units. Graph this new function. Okay, let's start with the given. Y equals 1/2 x squared. Thoughts on y equals 1/2 x squared? Okay, it's a parabola what? Okay, yep. A parabola but wider. Okay. Where's the vertex going to be? 0, 0. Okay. Normally when we put in 1, we'd get 1 out, yes? What about this one? When you put in 1, you're going to get a half. Basically, each of your outputs are going to be half of what they normally would. Normally, we'd put in 1, we'd get 1. Now it's going to be 1, comma, a half. Normally, you put in 2, you get 4. Half of 4 puts us at 2. If you want, I don't know, you could put in 3. Normally, you put in 3, you'd get 9 out, but half of 9 puts us at 4.5. And what do you know about a parabola? You also have to do the same thing on the other side. So left 1 up a half, left 2 up 2, left 3 up 4.5. Whoops. Remember, it should be U-shaped. And keep in mind, you can always do an XY chart if you feel that need, right? Which essentially what I talked you through. 0, 0, 1, 1/2, 2, 2, and 3, 4.5. Now, what are we being asked to do with this?
Shift the curve 3 units to the right and up 2.
Okay, 3 right, up 2. Okay. What's easiest to do here? Move the vertex and work from there? That's what's going to be easiest in my brain. As opposed to, you can make an XY chart, but, so if I move that vertex, where did we say we were going?
3 units to the right and up 2.
So 1, 2, 3, up 2. There's my new vertex. Now, if you want to plug in numbers that are right around 3, yes? It's like 4 and 5, 2 and 1. Or, can we use this from the vertex? What did we do? We went right 1, up a half. So from this vertex, could you do the same thing? We could go right 1, up a half. We could also go left 1 and up a half. From this vertex, you can go right 2, up 2. And then you can also do the same with 3, left and right 3, up 4.5. Thank you, Serenity. Okay. You guys got a curve that looks like mine? Similarly? Again, it didn't really ask us the equation, but why not? Y equals what? 1/2 stays out front. Parentheses. X minus 3, quantity squared, and then up 2, plus 2. Okay, so that's a parabola. That's what my Algebra 2 kids do a couple chapters down the road. We start with absolute values. Later we do the same thing with parabolas. Okay, let's look at example 3. Graph the function y equals 1/2 x. Then change the equation to shift the graph 2 units to the left and down 1 unit. Now let's start by doing the first thing they ask. What do you guys know about y equals 1/2 x? Okay. Straight line goes through the origin, slope of 1/2. Don't follow my lead. Okay, can't even see what I did. Rise 1, run 2. You can also reverse that and go down 1, left 2. Okay, change the equation to shift the graph 2 units left and down 1 unit. What happens here? If I take this center point and I go 2 units left and down 1 unit,
It's going to be the same thing.
I land on the line that's already there, don't I?
Yeah.
Okay. So does that translation do anything for this one? No. If we look at the equation, think about looking at the equation with me. It was y equals 1/2 times x, right? Well, if we put the translations in there, we're going to go 2 units left. What does 2 units left look like? X plus 2 in the parentheses. And then down 1 unit, minus 1. Do some math. We do some simplifying. Distribute the 1/2. I have 1/2 x plus half of 2 is 1 minus 1. What happens? It's the same line. Okay? Because the translations they were having me do were the same thing as the slope. Did you catch that before it happened or not until it happens?
Not so I was saying.
Okay.
I noticed that they were similar to what we were
This is matter of putting it all together. Okay, so that's a lot of the algebra review, yes?
Yeah.
Okay, that's all Algebra 1, Algebra 2 stuff. Now let's talk more like the pre-calc, calc level stuff. So I say that because in algebra you did not graph sine x. So y equals the absolute value of 4 sine x. Change the function to shift the graph down 2 and pi over 2 units to the right. The easy algebra just went out the door, didn't it?
Yeah, there's some pre-calc stuff.
easy of what it is.
I don't like these notes.
Throw them away. Let's
I
burn
need a
them.
new notebook.
Well, I don't know how much my algebra 2, and I think they were focused on their test, but there are several things that I said that could have directly helped them on their test. But
Wish we had that.
I would have stayed in here for the first 3 minutes.
Yeah,
Just
exactly.
listen like, now how can I fix this one?
yeah.
Yeah.
Okay.
Maybe
So
I'm confident you can do it right.
let's do some graphing here.
Graphing.
Let me set up a graph. Okay, so basic sign. Let's start with basic sign. What do you know when we're graphing basic sign?
Sums up to the
Yeah, it comes up through the origin. How far is a cycle? 2 pi. And we normally break that into quarters, yes? So the halfway point is pi. Put a mark at pi over 2 and at 3 pi over 2. Old news? I'm going to do the same thing on the left. I'm going to try and just continue my marks over there. So I have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay. Now, if I go okay, let me back up here. That 4. What's that 4 going to do? It's not the center line. Amplitude. The center line would be a number added or subtracted onto this. Okay, so this is the amplitude, which basically says what about this? Instead of going up and down to 1, we're going to go up and down to 4. Okay, to get us started, I'm going to lightly trace in. I'm using pencil instead of pen for this one. A sine. Let me rephrase that. A sine curve before anyone starts getting smart alecky with me. I was just waiting for someone to get smart alecky with me.
I was just trying to think of the way to frame it.
See, I caught you before you got there, though. Okay, so the sine curve, Daryl mentioned 0 earlier, right? What's it do? It goes up and has a max above pi over 2, has an intercept at pi, a minimum under 3 pi over 2, and an intercept at 2 pi again.
Yep.
And I know it's light up here. I'm going to reverse this and go the other way too, which means my minimum is under negative pi over 2, intercept at negative pi, max above negative 3 pi over 2, and intercept at negative 2 pi again. Did you guys go as high as 4 and as low as negative 4? Okay, so that right there is 4 sine x. What's the absolute value of 4 sine x look like?
It cannot go under.
Okay, flip the stuff that's underneath on top. So basically, I'm going to take, so like the 2 mountains that are on top are good, yes? This mountain that's down below now needs to be a pi. This mountain is up high, and that mountain is up high, yes? Are we good with what I have right here? This is y equals absolute value of 4 sine x. Now, what were we asked to do?
Shift that boy.
We need to go down 2 and pi over 2 units to the right. So, I would think something like 0, 0. It needs to go where? Down 2 and right pi over 2. Could you put each of those pieces in their new spots? Can we put dots here? So I have a point at pi, yes? If I move it down 2 and pi over 2 to the right, it's right underneath 3 pi over 2, yes? Do you see what I'm doing here? The 2 pi would be off the graph. I'm going to do the same thing with the other one. The one that's at negative pi, it's going to be directly under negative pi over 2. The one that's at negative 2 pi, directly under negative 3 pi over 2. So those 4 dots right there are kind of my new minimums. Can you do the same thing with your mountaintops? Like my vocabulary here? Okay, so if I take this mountaintop here and I move it pi over 2 right, I'm now at negative pi. 2 down means I'm now at 2. And it ends up between the two mountains that are there. Can I do that with each of these? Move it to the one that's over negative pi over 2 is now going to be on the y-axis. The one that's over pi over 2 is now going to be above pi. The one that's above 3 pi over 2 is now going to be above 2 pi. And technically, there's one I don't have here because we didn't have anything to shift. What's going to be happening at negative 2 pi? If you follow the pattern, there'd be a point 2 up, yes? Can you connect these? Do me a favor and want to. Is that what I'm drawing?
My drawing is not okay.
It's not okay.
No, it's not okay.
Mine just looks like a big old hot mess.
Mine does too.
I mean,
I made a different graph.
that's fine.
I should have done that.
Okay. Now, this was originally y equals the absolute value of 4 sine x, correct? What does the new equation look like then? It's y equals absolute value 4 sine. What do you have to do to the x? Throw it in parentheses, and since it was pi over 2 to the right, we're going to say x minus pi over 2. In parentheses, and absolute value, and then the down 2 is minus 2. So that is the equation that represents what we just did. And if you need some labels, you know, our 4 was our amplitude. We did a sine curve. The pi over 2 was right pi over 2. The minus 2 was down 2. And the absolute value made us flip everything up. So if you need any of those labels, get them on there. Okay. Flip over to the back when you're ready. Start looking at example 5. I'm going to challenge you to say, let's do this without the use of the calculator. I just want to make a connection here is what I want to do. Underneath this are the Zoom standard graphs of the functions. So they're saying f of x is this, g of x is this, h of x is this. That's what those 3 graphs are in that graph. For each graph, determine the corresponding function. So, my question to you, without grabbing your calculators, just using the equations and the graphs there, how can you tell me which is which? What do you think, Vincent?
You could use the constants at the end of the equation, which represent the y-intercept, to determine which one is which.
I agree. Okay, so for instance, if I look over here at h of x, okay, basically, he's putting 0 in for x is what he's doing. Okay, but the idea that if you put 0 in there, you're going to get negative 3, and that is the y-intercept. Which graph has a y-intercept of negative 3? That one right there. So this graph is h of x. Okay? So the point is that, there is, even though these are funky graphs and everything, if I'm going backwards, I guess, what about g? G has a y-intercept at 6, so
It's the top one.
it's the top one. And what about F?
The middle. Because it has.
Has no constant, so that means it has a y-intercept of 0. So that is the one that's hidden in the middle here. Just basic graph knowledge is what that's supposed to be. Basic reminder there. But those are all y-intercepts is what those were. Okay. So we've had our Algebra 2. Now we're going to talk pre-calc. I say this because I just taught my kids their 12 basic graphs this week. Okay. Actually, they had to start learning them on their own via e-learning. I made them graph them on their own for e-learning. But then we went over them in class and, all the details and stuff. Do you remember what 1 over x is?
I remember the thing that looks like stairs.
Nah, this is not the stairs. Okay. 1 over x is called the reciprocal function. Do you remember what the reciprocal function looks like? Do we know what the graph of 1 over x looks like?
Like a graph.
So I'm going to go with that's a big old no. We don't
I
remember.
don't remember.
What if I say the word hyperbola?
Oh, yeah, the use.
Okay. It's a hyperbola in the first and third quadrants.
Oh, yeah, I remember now.
This is the first graph on the second row. I don't know how much,
Yeah, that does not help. That does not help.
For me, that does a lot, and I've been through these pre-cal notes a few years, so I kind of have them visualized like
Where each one is.
where they are for the most part. So, okay. Now I put dots. There's not a lot of values here you can use. I mean, you can put 1 in. 1 over 1 is 1, so there is a point at 1, 1. But other than that, remember that the x and y axis are running as asymptotes. Yes. I mean, once I draw it up there, you know what to do with it, I think. Okay.
We brought up the word hyperbola whenever we were doing that ellipse. That's the only reason why I remembered what those were.
Oh, well, because we did just talk about it, didn't we?
Yeah.
Okay, what about example 7? Graph this by using the translations.
Great.
Right 3 up 2.
Okay. You guys are laughing, but come on. Right 3.
Yes.
You guys can do this part. Right 3 up 2. That's doable, yes? So we're going to take what we just had here and go right 3 up 2. My best suggestion, the x and y axis act as asymptotes. So can you take your asymptotes and move them right 3 up 2? That's what I would suggest. So if I move my asymptotes right 3, that means I now have a vertical asymptote at x equals 3. And if I go up 2, that now means I have a horizontal asymptote at y equals 2. Can you draw in your hyperbolas?
Yes, ma'am.
Yeah. So I'm going to have a hyperbola up here in the top right corner and a hyperbola down here in the bottom left corner. Okay. And example 8. I'm going to do 3 separate graphs here. A graph for A, a graph for B, a graph for C.
Do you ever say a word so much that it just sounds weird? When you just repeat it so many times where it doesn't even sound like a word anymore. I do that a lot. Like the word does, I was trying to spell it and it did not. It was like, this doesn't look like a word.
Okay. Thoughts on A? Y equals negative 1 over x.
It's reflected of yes.
That negative is a reflection.
Yeah. Big boy moves.
Officially, if the negative is out front of the function, we call it a reflection over the x-axis. However, you could just as easily take that negative and put it directly on the x here, and it's reflection over the y-axis. Because in this particular graph, a reflection of across the x or y is going to result in the same graph. Basically, what's the short of it? Instead of being quadrants 1 and 3,
2 and 4.
2 and 4. Thoughts on B?
It's reflected and add 3. So it would be the left.
It's reflected and shifted to the right.
Yeah.
This is where it gets tricky. Okay, my recommendation on this one, because these are a struggle.
It would be to the left.
Okay, first of all, what we need to do here is,
Negative x
if I reverse this, it's negative x plus 3. And what is common practice here is to factor a negative out. If I factor a negative out of that denominator, it's negative, and then in the parentheses would be, if I factor the negative out, it's now x minus 3. Okay. And so, trying to think. If we look at this one, it's a reflection, which we already taught, we knew that. And then this minus 3 tells us right 3. I'm trying to think, trying to visualize. Okay, that's how that one's done. What if, I don't think that works. Okay. Did you graph it? We're going to go right 3. Basically, that means our vertical axis is now right 3. And what's the reflection have us do? Yeah, instead of the idea of quadrants 1 and 3, it's the idea of quadrants 2 and 4. So it looks something like that. Okay, I'll be honest, when you get that translation and that reflection in there, you have to be very careful. I tend to goof those up if I'm not careful. Okay, C. Y equals 1 over x squared. What's that square do?
No, makes it
Closer to the line of survey.
What'd you say? I just couldn't hear you.
If you get closer to the line of survey, right? The asymptote.
Get closer to the Y, and I still missed the end. Sooner? Well, it moves one of the pieces of the graph, though. And that's the big thing we have to talk about. I mean, it is going to, yes, I think it is going to be go up quicker type thing. Yeah. But, okay, so what did that absolute value do to that sign earlier? Anything that was negative, it flipped it and made it positive. What happens when you square something? If you square a positive value, it's going to stay positive. If you square a negative value, it's going to become positive, right?
That's in the negative under the positive.
So that means the curve in quadrant 1 stays up there. The curve that's in quadrant 3
Goes to quadrant 2.
goes to quadrant 2. And so both pieces are up top, is what we're looking at here. And again, I'm not getting specific with my, and I do agree it would go up steeper, but more importantly is that both pieces are up top, because when you square that negative, it makes it positive.